Hi everyone, this is our team's presentation on machine learning. Today we're going to talk about a machine learning model we trained to learn our actions and then try to guess them by our recorded data. We'll walk you through how we built the model, what it does, and what we learned from testing it.
I'm Chie, the person in the video doing the data recording. The motion we're recording is the lie-down motion. To collect the data, we use MATLAB Mobile, which was synced with the desktop version of MATLAB. I secured the phone to my hand and used its built-in accelerometer to capture the motion data. After pressing start on the MATLAB mobile app, the app recorded the motion data and saved it to my computer, where it was later used for analysis.
So this is how we extracted our data. We started out with doing our tests and receiving the data from an accelerometer on our phone. The sensor tracked how fast it moved in three directions, that was in the left and right, up and down, and forward and backward directions. Each of these files we used came from a different human activity like brushing teeth, walking, or drinking water. And then for this instance, we were just looking at the sitting down movement. These files were stored in the folders that were named after the activity that was being done. And inside of each of these files, there were hundreds or even thousands of rows of data values collected. Since that accelerometer data is very detailed and noisy, we needed to simplify it into a small set of numbers that would still describe the overall motion. To do this, we wrote a MATLAB function called extract acceleration features, which just extracted 5 important features from each file. These features are like, summaries how fast the person is moving. For example, the average acceleration in the x and y directions would tell us how much movement is happening sideways or up and down. The resultant acceleration gives us a measure of how strong the movement is, and the standard deviation would show us how much vertical movement is changing. And lastly, we measured the average time between peaks in the y direction, and that would help detect repeating movements like back and forth motion when brushing. These 5 features were chosen because they gave us the most useful information while keeping things simple. After extracting the data, we then needed to process the data. So I'm going to go into how our team processed the data. First, we extracted the 5 features from each motion file. Then we needed to organize the data so it could be used to train the machine learning model. For each file, we added a label that told us what activity the person was doing, like brushing their teeth, walking, or lying down. We combined the features and labels into one big table called the reference table. Each row of the table represented one file, and the columns held the 5 features plus the activity label. In total, we ended up with 340 rows and one row for each file and one column for each feature plus a label. This was important because the machine learning models needed a structured data to work correctly. By putting everything into a single table, we made it easy to feed the data into a training algorithm. This structure also helps us clearly see how different activities compare based on their movement. And once the table was complete, we could test different models to see how well they could learn and identify each activity just by looking at the 5 features. And this processing step helped us go from the messy raw sensor data to clean and labeled data that the machine learning models could understand and learn from.
So right here, the data processing. So we're just cleaning up the data before using it in the model. Raw data usually has mistakes, missing values, or just numbers that are on very different scales. We fix those problems by filling in or removing bad data. then scaling everything so one feature doesn't overpower the other. And from the categories, we turn those into numbers so the model can actually work with them. Basically, this step makes sure the data is in the right shape and quality for the machine learning model to learn from. Okay, and then the predicted results side. So after the data is processed and fed into the model, we finally get predictions. The prediction can take different forms depending on the type of the problem. If it's a classification problem, the model gives us a label like walking, running, or standing. If it's regression, it might give us a number like predicting someone's speed or how long an activity will last. In our project, the model is basically mapping patterns in the motion data to an activity type. Think of it like recognizing a fingerprint. Every activity has its own pattern, and the model learns to match those patterns to the right label. But predictions on their own don't mean much until we test them. We compare them with the actual results to see if the model was right. This evaluation gives us accuracy, error rates, and other metrics that tells us how good the model really is. So in short, this slide is about showing the model's output, reminding everyone that predictions are only useful if we check how close they are to reality.
To wrap everything up, our prediction was incorrect from the model, but we can further refine the code to get better accuracy. And from what we learned, not everyone has the same habits and movements, so if we could record more data, we could have a better general data set, and this data set would be able to predict our actions more clearly.